Hello, in this lecture we'll find out the radius of a circle. In the drawing we have a circle. Inside the circle we have chord DB. The length of chord DB is 2 units. We also have chord AC. The length of chord AC is square root of 2 units. And we also have here, this is angle DAB. The size of this angle DAB is 45 degrees. Again, our mission is to find out the radius of this circle. So in the first step, we'll join points A and D together by straight line. By joining points A and D, we create there angle peripheral angle DAB. This is peripheral angle DAB. We'll define the length, the side of this peripheral angle DAB as x over 2. So peripheral angle DAB is subtended on chord DB. The next step, we'll define the center of this circle. This point is point O. We'll join points O and D together by a straight line. And we'll join points O and B together by a straight line. By doing this construction, we created here center angle DOB. This is center angle DOB, and this center angle DOB is also subtended on chord DB, exactly like this peripheral angle DAB. It is also subtended on the same chord DB. So now we can implement here rule 13. So I'll repeat quickly on rule 13. According to rule 13, the central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle. Inside the circle we have peripheral angle ACB. The size of this peripheral angle ACB is theta, and peripheral angle ACB is subtended on chord AB. Likewise, we have inside the circle also central angle AOB. This central angle AOB is also subtended on the same chord AB. So those two angles, they are both subtended on the same chord AB. And therefore, according to this rule, rule 13, the size of this central angle AOB will be twice as large as the size of this peripheral angle ACB. The size of this peripheral angle ACB is theta, and therefore the size of this peripheral angle AOB must be equal to 2 theta. Why? Because of the fact that both of them, they are subtended on the same chord AB. Okay, so the size of a peripheral angle will be always twice as large as the size of the peripheral angle that is subtended on the same chord. Okay, so actually we can implement rule 13, this rule, in our drawing. In our drawing, those two angles, they are both subtended on the same chord DB. The size of this peripheral angle DAB is x over 2, and therefore the size of this central angle DOB that is subtended on the same chord DB will be twice as large as the size of this peripheral angle DAB. The size of this peripheral angle is x over 2, and therefore the size of this central angle DOB will be equal to x over 2 times 2, that is x. According to rule 13, of course. In the next step, we will define the size of this peripheral angle AGC. This angle is y over 2. So peripheral angle ADC is subtended on chord AC, and the size of this peripheral angle ADC is y over 2. In the next step, we will join points O and C together by a straight line. We join points So we join points O and C together by a straight line. Likewise, we join points O and A together by a straight line. By doing this construction, we created the central angle AOC. This is central angle AOC, and this central angle AOC is subtended on chord AC, exactly like this peripheral angle ADC, that is also subtended on the same chord AC. So now we can implement the Rule 13. Why? Because both those two angles, they subtended on the same chord AC. The size of this peripheral angle ADC is y over 2, and therefore the size of this central angle AOC that is subtended on the same chord AC must be equal to y over 2 times 2, that is y. According to Rule 13, of course. Okay. In the next step, I'll copy the green triangle ADA, this green triangle ADA, in the new page, and then we will implement on this green triangle ADE Rule 4. Okay. Actually, this is triangle ADE, the green triangle ADE that I copied from the original drawing. Inside triangle ADE, we have those two angles, and also this is angle AED. So all those three angles, they are located inside triangle ADE, and therefore they are defined as the interior angles of the triangle ADE. So write it down. All those three angles now defined as the interior angles of this triangle AD. While this is angle BED, this angle BED is located outside triangle AED, and therefore it is defined as the exterior angle of this triangle AD. So write it down. This is the external angle of triangle ADE. So in the drawing we have three internal angles, and this is the external angle. Angle BED is the external angle of this triangle, triangle AD. So in the next step, I will present to you rule 4, and we will implement rule 4 in this triangle, triangle AED. So according to rule 4, the external angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles A, B and C. They are all located inside the triangle, and therefore they are defined as the interior angles of this triangle, while this angle is located outside the triangle, and therefore this angle E is defined as the external angle of this triangle. According to this rule 4, the side of this external angle E of this triangle is equal to the sum of the two interior angles that are not adjacent to it. This is the interior angle C that is definitely adjacent to angle E. The two other angles that are not adjacent to this angle E are those two angles, A and B. Those are the two interior angles that are not adjacent to angle E. And the sum of those two angles is A plus B, and the size of this interior angle E is equal to the sum of the two interior angles that are not adjacent to it. That is to say, A plus B. So in covariant forward, the size of this external angle E is equal to A plus B. Okay, the size of the external angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. This is the interior angle E, and the sum of the two interior angles that are not adjacent to it is A plus B. So angle E equals to the size of angle E is A plus B. So I can actually implement rule 4 in our drawing. Why? Because in our drawing we have this is the external angle of this triangle AD. According to rule 4, the size of the external angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is the interior angle DEB that is definitely adjacent to this angle BED. The two other angles that are not adjacent to this angle BED are those two angles. So the size of the external angle BED will be equal to y over 2 plus x over 2. That is actually the sum of the two interior angles that are not adjacent to it. So in conclusion, we found out that according to rule 4, the size of the external angle BED is equal to x plus 2 plus y over 2. So I write it down. So according to rule 4, the size of the external angle BED is equal to the sum of the two interior angles that are not adjacent to it. That is to say, it is x over 2 plus y over 2. According to rule 4, of course. But it is given as the question that the external angle BED is equal to 45 degrees inside. So you can substitute angle BED by 45 degrees. So 45 degrees equals to x over 2 plus y over 2. So here we multiply this equation by 2, and we get that 45 degrees times 2 is 90 degrees. So 90 degrees equals to x over 2 times 2 is x, and y over 2 times 2 is y. So it is x plus y. Here we subtract x from this equation, and finally we get that 45 degrees times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is 90 degrees, and 2 times 2 is 90 degrees. So 2 times 2 is y equals to 90 degrees minus x. So according to equation 1, y equals to 90 degrees minus x. In the next step, I repeat on the law of cosines quickly, and then we'll implement the law of cosines on triangle BOD and also on triangle OCA, on those two triangles. So the law of cosines is true in any triangle. This is triangle ABC, that could be any triangle. In triangle ABC, side AB is equals to A unit in its length, side AC equals to B unit in its length, and side BC equals to C units in its length. This is angle BAC, the size of this angle BAC is theta. So this triangle ABC, that could be any triangle, the following equation will be true, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. You can actually implement the law of cosines in any triangle. Therefore, we will implement the law of cosines in this triangle, triangle ODB. So I copy this triangle ODB in the new page, and we will implement the law of cosines in this triangle, triangle ODB. But before that, what is the length of line segment OD? Line segment OD starts from point O, that is the center of the circle, and that's the point D, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OD is the radius of the circle. The radius of the circle is the radius that you are looking for in this question. We define the radius of this circle as R, so OD equals to R. Likewise, OB also equals to R. OC equals to R. And OA also equals to R. So in the next step, I'll copy triangle OBD in a new page, and we'll implement the law of cosines in this triangle, triangle OBD. Side DB equals to 2 units in its length, according to what is given us the question. So actually, this is triangle OBD, that is copied from the original drawing. So now we'll implement the law of cosines in this triangle, triangle OBD. According to the law of cosines, cosine x equals to OD squared plus OB squared minus DB squared over 2 times OD times OB. So write it down. According to the law of cosines in this triangle, triangle OBD. So cosine x equals to OD square. OD is R, therefore OD square is R square plus OB square. OB is also R, therefore OB square is R square. So it is plus R square minus DB square. DB is 2, therefore DB square is 2 squared, that is 4. So it is minus 4 divided by 2 times OD. OD is R times OB. OB is also R. So you can found out that according to the law of cosines, in triangle OBD, the following equation is true, that cosine x equals to R square plus R square minus 4 over 2 times R times R. R square plus R square is 2R square, so in total, in the numerator, we have 2R square minus 4 divided by 2 times R, that is 2R square. So we found out that cosine x equals to 2R square over 2R square is 1, and we have also here minus 4 over 2R square. So according to equation 1, cosine x equals to 1, and we have here this expression, we divide both the numerator and the denominator of this expression by 2. Minus 4 over 2 is minus 2, and 2R square over 2 is R square. So we found out that according to equation 1 and the law of cosines, in triangle OBD, cosine x equals to 1 minus 2 over R square. In the next step, I'll copy triangle OSC in a new page, and we will implement the law of cosines in this triangle, triangle OSC. Side AC equals to the square root of 2 units in itself, according to what is given as the question. OA equals to R, and OC also equals to R. So actually, this is triangle OSC. This is according to the original drawing. In the next step, we will implement the law of cosines in this triangle, triangle OSC. So according to the law of cosines in this triangle, triangle OSC, cosine y equals to OA square. OA is R, therefore OA square is R square plus OC square. OC is also R, therefore OC square is R square minus AC square. AC is square root of 2, therefore AC square is square root of 2 square, that is 2. So it is minus 2 divided by 2 times OA is R times OC is also R. So in conclusion, we found out that according to the law of cosines, in equation 2 we have cosine y equals to R square plus R square minus 2 over 2 times R times R. So R square plus R square is 2R square. So in total, in the numerator of this expression, we have 2R square minus 2 divided by 2 times R, that is 2R square. So here 2R square over 2R square is 1, minus 2 over 2 r squared. So if we found out that cosine y equals to 1, and we have here minus 2 over 2 r squared. Here we'll divide both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, and 2r squared over 2 is r squared. So we found out that cosine, according to equation 2, cosine y equals to 1 minus 1 over r squared. So cosine y according to equation 2 equals to 1 minus 1 over r squared. This is according to equation 2. Well, we already found out that y equals to 90 degrees minus 6. So write it down. We already found out that y equals to 90 degrees minus 6. And therefore we can substitute y in this equation by 90 degrees minus x. So we do it now, and we get that according to equation 2, we have cosine y, and y is 90 degrees minus x, equals to 1 minus 1 over r squared. It again, actually found out that according to equation 2, cosine 90 degrees minus x equals to 1 minus 1 over r squared. Here we use the following trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So according to this trigonometric identity, you can substitute cosine 90 degrees minus x by sinus x. We'll do it now, and we get that according to equation 2, we have cosine 90 degrees minus x, that is sinus x according to this trigonometric identity. So sinus x according to equation 2 equals to 1 minus 1 over r squared. This is according to equation 2, while according to equation 1, we already found out that cosine x equals to 1 minus 2 over r squared. So actually we have here the values of sinus x and cosine x in terms of r. So in the next step, we use the following trigonometric identity that states that sinus square x plus cosine square x equals to 1. According to equation 2, sinus x equals to 1 minus 1 over r squared. If sinus x equals to 1 minus 1 over r squared, it means that sinus square x will be equal to 1 minus 1 over r squared squared. So I write it down, this will be equation 3. So according to equation 3, sinus square x is 1 minus 1 over r squared. So this is sinus square x plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r squared. So if cosine x equals to 1 minus 2 over r squared, it means that cosine square x will be equal to 1 minus 2 over r squared. Okay? And according to this trigonometric identity, it is equal to 1. So here also it will be equal to 1. In the next step, we define t as 1 over r squared. So now we can substitute 1 over r squared in this equation 3 by t. We do it now, and we get that according to this equation 3, we have 1 minus 1 over r squared. 1 over r squared is t. So we substitute 1 over r squared by t. So in total this expression will be equal to 1 minus t squared plus, we have here 1 minus, here we multiply this expression by 1. It is allowable to multiply any expression by 1 by multiplying the expression by 1. We will not change the value of the expression, and therefore it is allowable to multiply this expression by 1. So this expression in total will be equal to 1 minus 2, and 1 over r squared is t. So we substitute 1 over r squared by t. So in total this expression will be equal to 1 minus 2t squared. And it is equal to 1. So in conclusion, according to equation 3, we actually found out that 1 minus t squared plus 1 minus 2t squared equals to 1. So here we'll open the brackets on this side of this equation 3. And we get that according to this equation 3, we have 1 minus t squared. 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t. And we also here plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1. Plus 2t squared. 2t squared is 4t squared. Minus 2 times 1 times 2t. Minus 2 times 1 times 2t is minus 4t. And it is equals to 1. So here we have 1 on both sides of this equation 3. So 1 will get cancelled. After we cancel 1, in this side of equation 3, we will have t squared plus 4t squared is 5t squared. And we have also here minus 2t minus 4t is minus 6t plus 1 equals to 0. So, actually found out that according to equation 3, equation 3, 5t squared and 6t plus 1 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared plus 4 times a times c over 2a. In our specific quadratic equation, that is to say, five t squared minus 6t plus 1 equals to 0. The variable that we're looking for is t, so x equals to t. The coefficient a equals to 5. The coefficient b equals to minus 6. And finally, the coefficient c equals to 1. So actually, the only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we'll find out the values of t, because x equals to t. So we do it now, and we get here that x equals to t, so we substitute x by t, and it is equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36. Minus 4 times a is 5, so minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20. So inside the root we have only 36 minus 20 divided by 2a. A is 5, so 2 times a is 2 times 5, that is 10. So actually found out that t equals to 6 plus minus, inside the root we have 36 minus 20. 36 minus 20 is 16, so inside the root we have to only have 16 divided by 10. So I found out that t equals to 6 plus minus, and the square root of 16 is 4 divided by 10. Repeat again. Actually found out that t equals to 6 plus minus 4 divided by 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So according to the first solution for t equals to 1 from one side, but from the other side, according to our definition, t also equals to 1 over r squared. Again, according to our definition, t equals to 1 over r squared. Therefore, we can substitute t in this equation by 1 over r squared. We'll do it now, and we'll get that 1 over r squared equals to 1. So here we multiply this equation by r squared, and finally we get that r squared equals to 1. Here we take a root out of this equation, and we get that r equals to the square root of 1, that is 1. So according to the first solution for t, the radius of this circle r equals to 1. But it is actually impossible that the radius of this circle will be equal to 1. I'll explain why. Because of the fact that we know that chord dB equals to 2 units in itself, according to what is given as the equation. So dB equals to 2, and it is very clear from the drawing that chord dB is definitely not the diameter of the circle. Again, chord dB is not the diameter of the circle. So I write it down. Actually, you can see it very clear from the drawing that chord dB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. What is the diameter of this circle? The diameter of this circle is of course 2r. So we know that the diameter 2r is the longest chord in the circle, therefore it will be definitely greater than dB, that is not the diameter of the circle. Again, the diameter 2r must be greater than dB, that is not the diameter of the circle. dB equals to 2. From this equation, we derive that 2r is greater than 2. Here we will divide this inequality by 2 and finally get that the radius r is greater than 1. The radius r of this circle is greater than 1 unit. So if the radius r is greater than 1, the radius of the circle cannot be equal to 1. So this solution is an incorrect solution. So the first solution for t, that t equals to 1, gave us a contradiction, and therefore the first solution for t is incorrect solution. T cannot be equal to 1, and we take into account only the second solution for t. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So if we found out that the second solution for t is that t equals to 1/5 from one side, but from the other side, according to our definition, t is also equals to 1 over r squared. And therefore, we can substitute t in this equation by 1 over r squared. We do it now, we get that 1 over r squared equals to 1/5. Here we first multiply this equation, and finally we get that r squared equals to 5. So here we'll take out of this equation, and finally we get that the radius r that we are looking for, the radius r of the circle, equals to either the square root of 5 units in its length, or in terms of numbers is equals to 2.236 units. And this is the answer to the question, so I'll repeat again. If we found out that the radius r of this circle equals to either the square root of 5 units in its length, or in terms of numbers, this equals to 2.236 units. Okay, so in the next step I will summarize the lecture. In this lecture we found out the radius of this circle. So in the drawing we have a circle. Inside the circle we have chord dB. The size of chord dB is 2 units. We also have chord AC. The size of chord AC, the length of chord AC is chord of 2 units. In addition we have here, this is angle BAD. The size for angle BAD is 45 degrees. Again, our mission is to find out the radius of this circle. So in the first step, we joined points A and D together by a set time. By joining points A and D, we created here peripheral angle DAB. This is peripheral angle DAB. We define the size of this peripheral angle DAB as x over 2. So this is peripheral angle DAB that is subtended on chord DB. In the next step, we join points O and D together by a straight line, and also we join points O and B together by a straight line. By doing this construction, we get the set triangle DOB. So this is set triangle DOB, and this set triangle DOB is subtended on chord DB, exactly like this triangle BAD. This is also subtended on the same chord called DB. So now we can implement here Rule 13. Well, because we have here two angles, and both of them they subtended on the same chord called DB. So, and therefore we can implement Rule 13. According to Rule 13, a certain angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle. Inside the circle we have peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. In addition, inside this circle we have center angle AOB. This is center angle AOB, and this center angle AOB is also subtended on the same chord called AB. So those two angles, they are both subtended on the same chord called AB, and therefore, according to this rule, Rule 13, the size of this center angle AOB will be twice as great as the size of this peripheral angle ACB. The size of this peripheral angle ACB is theta, and therefore the size of this peripheral angle AOB that is subtended on the same chord called AB will be equal to 2 theta. Okay, so we can actually implement this Rule 13 in our drawing. Why? Because in our drawing those two angles, they are both subtended on the same chord called DB. The size of this peripheral angle DAB is x over 2, and therefore the size of this center angle DOB that is subtended on the same chord called DB must be equal to x over 2 times 2, that is x, according to Rule 13, of course. In the next step, we define the size of this peripheral angle DC. The size of this peripheral angle, we define the size of this peripheral angle ADC. This peripheral angle ADC is y over 2. This peripheral angle ADC is subtended on chord AC. In the next step, we join points O and C together by a straight line, and we join points O and A together by a straight line. By doing this construction, we can do center angle AOB. This is center angle AOB, and this center angle AOB is subtended on chord AC, exactly like this peripheral angle ADC that is also subtended on the same chord called AC. So those two angles, they are both subtended on the same chord called AC. And therefore, according to Rule 13, the size of this center angle AOB will be twice as large as the size of this peripheral angle ADC. The size of this peripheral angle ADC is y over 2, and therefore the size of this center angle AOB must be equal, that is subtended on the same chord called AC, must be equal to y over 2 times 2, that is y. Okay? So, in the next step, we copy the green triangle DEA in a new page, and we implemented Rule 4 in this triangle DEA. This is triangle DEA, that is copied from the original drawing. This triangle DEA. Inside triangle DEA, we have 1, 2, 3 angles. And because of the fact that they are located inside the triangle, all of those 3 angles, this is angle DEA, this angle is y over 2, this angle equals to x over 2 degrees inside. So all of those 3 angles are defined as the interior angles of this triangle DEA, because they are located inside the triangle. While this is angle BED, that is located outside triangle DEA, and therefore it is defined as the exterior angle of this triangle, triangle DEA. So, in the next step, I actually presented to you rule 4, and we implemented rule 4 on this triangle, triangle DEA. So I repeat quickly on rule 4. According to rule 4, the exterior angle of a triangle is equal to the sum of the two interangles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles A, B, and C. And because of the fact that they are located inside the triangle, they are defined as the interior angles of this triangle. While this is angle E that is located outside this triangle, and therefore it is defined as the exterior angle of this triangle. According to this rule 4, the size of this exterior angle E will be equal to the sum of the two interior angles that are not adjacent to it. Again, it will be equal to the sum of the two interior angles that are not adjacent to it. This is angle C, this interior angle that is definitely adjacent to angle E. The two other interior angles that are not adjacent to this angle E are A and B. And the sum of those two angles is A plus B. So the size of angle E equals to the sum of the two interior angles that are not adjacent to it. That is to say, A plus B. So the size of angle E is equal to A plus B. A plus B is the sum of the two interior angles that are not adjacent to this angle E. So actually we can implement this rule in our drawing. This rule will fall in our drawing. Why? Because in our drawing we have the exterior angle BED. This is the exterior angle BED. So according to rule 4, the size of this exterior angle BED, it must be equal to the sum of the two interior angles that are not adjacent to it. This is the interior angle AED that is definitely adjacent to this angle BED. The two other interior angles that are not adjacent to this angle BED are those two angles. And according to rule 4, the size of the exterior angle BED is equal to the sum of the two interior angles that are not adjacent to it. That is to say, the size of the exterior angle BED, it will be equal to x over 2 plus y over 2. Again, according to rule 4, the size of this exterior angle BED will be equal to the sum of the two interior angles that are not adjacent to it. The two interior angles that are not adjacent to it are x over 2 and y over 2. And the sum of the two interior angles that are not adjacent to it is x over 2 plus y over 2. So in conclusion, we found out that the size of this exterior angle BED according to rule 4 is equal to x over 2 plus y over 2. Repeat again, according to rule 4, the size of this exterior angle BED of this angle ADE is equal to x over 2 plus y over 2. So angle BED equals the exterior angle BED equals to the size of the exterior angle BED is x over 2 plus y over 2. It's given us the question that the size of the exterior angle BED is 45, so we can solve again BED by 45. So we found out that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2 and finally found out that 45 degrees times 2 is 90 degrees. So 90 degrees equals to x over 2 times 2 is x and y over 2 times 2 is y. So in conclusion, we found out that 90 degrees equals to x plus y. Here we subtracted x from this equation and finally found out that y equals to 90 degrees minus x. So according to equation 1, y equals to 90 degrees minus x. In the next step, I repeated on the law of cosines and we implemented the law of cosines on those two triangles. Triangle DOB and this triangle AOC. So I repeat again on the law of cosines quickly. According to the law of cosines, first of all, the law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. This triangle ABC, the length of side AB is A, side AC equals to B units in its length, and side BC equals to C units in its length. This is angle BAC. The size of this angle BAC is theta. So according to the law of cosine, this law, in this angle ABC that could be an angle, the following equation will be true. That cosine theta equals to a square plus b square minus c square over 2 times a times b. Again, cosine theta equals to a square plus b square minus c square over 2 times a times b. We can actually implement the law of cosines in a triangle, and therefore we can implement the law of cosines in this triangle BOD. So call it triangle BOD in a new page, and we implemented the law of cosines in this triangle BOD. This is triangle BOD that according to the original drawing. We know that OB equals to OD equals to OA equals to OC. They are all the area of the circle. We define the radius of the circle as R, and therefore all those 4 line segments are the area of the circle. Therefore each of them is equals to R. It is the radius of the circle that is equal to R. So this is triangle OBD that according to the original domain, OD equals to OB equals to R, and OB equals to 2 units in length according to what is given as the question. So according to the law of cosines, in this triangle OBD, cosine x equals to OD square plus OB square minus DB square over 2 times OD times OB. So cosine x equals to OD square. OD is R, therefore OD square is R square, plus OB square. OB is also R, therefore OB square is R square, minus DB square. DB is 2, therefore DB square is 2 square, that is 4. So it is minus 4 divided by 2 times OD is R times OB, that is also R. So in total, in the denominator we have 2 times R times R. So according to the law of cosines, we actually found out that cosine x equals to R square plus R square minus 4 over 2 times R times R. R square plus R square is 2R square. So in total, in the denominator of this expression, we have 2R square minus 4 divided by 2 times R, that is 2R square. So here we have cosine x equals to 2R square over 2R square is 1. And we have minus 4 over 2R square. So here we divided both the numerator and the denominator of this expression by 2. We found actually that minus 4 over 2 is minus 2, and 2R square over 2 is R square. So in total we actually found out that cosine x equals to 1 minus 2 over R square. Again, according to equation 1, we actually found out that cosine x equals to 1 minus 2 over R square. In the next step, I complete this triangle AOC in the page, and we implemented the law of cosines in this triangle AOC. So actually, this is triangle AOC that are going from the original domain. Side AC equals to the square root of 2 units, AO equals to OC equals to R. This is again AOC, this is again Y. So according to the law of cosines, this triangle AOC, cosine Y equals to AO square plus CO square minus AC square over 2 times AO times CO. So cosine Y equals to AO square. AO is R, therefore AO square is R square, plus OC square. OC is also R, therefore OC square is R square, minus AC square. AC is square root of 2, therefore AC square is square root of 2 square, that is 2. So it is minus 2 divided by 2 times AO, that is R, times CO, that is also R. So it is 2 times R times R. So in conclusion, we found out that according to equation 2, cosine y equals to r squared plus r squared minus 2 over 2 times r times r. R squared plus r squared is 2r squared. So in total, in the numerator of this expression, we have 2r squared minus 2 divided by 2r times r is 2r squared. So 2r squared over 2r squared is 1, and we also here minus 2 over 2r squared. Here we divided both the numerator and the denominator of this expression by 2. Minus 2 over 2 is minus 1, and 2r squared over r squared is r squared. So we actually found out that according to equation 2, cosine y equals to 1 minus 1 over r squared. This is according to equation 2. Well, we already found out in the beginning of the lecture that y equals to 90 degrees minus x. Therefore, we can substitute y in this equation 2 by 90 degrees minus x. We did it, and we found out that according to this equation 2, cosine y is cosine 90 degrees minus x, so cosine 90 degrees minus x equals to 1 minus 1 over r squared. Repeat again. Actually found out that cosine 90 degrees minus x equals to 1 minus 1 over r squared. So here we use the trigonometric identity that states that sin of x equals to cosine 90 degrees minus x. So according to this trigonometric identity, we can substitute cosine 90 degrees minus x by sin of x. We did it. We actually found out that cosine 90 degrees minus x is sin of x, according to this trigonometric identity. So sin of x equals to 1 minus 1 over r squared. This is according to equation 2, and according to equation 1, we already found out that cosine x equals to 1 minus 2 over r squared. So we have the expressions of the values of sin of x and cosine x in terms of r. R is the radius of the circle that we are looking for. In the next step, use the trigonometric identity that states that sin of square x plus cosine square x equals to 1. According to equation 2, sin of x equals to 1 minus 1 over r squared. If sin of x equals to 1 minus 1 over r squared, it means that sin of square x will be equal to 1 minus 1 over r squared. And we have also here plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r squared. If cosine x equals to 1 minus 2 over r squared, it means that cosine square x will be equal to 1 minus 2 r squared squared. And according to this trigonometric identity, this equals to 1. Here we multiply this expression by 1. It is allowable to multiply any expression by 1, because by multiplying the expression by 1, you will not change the value of the expression. In the next step, we define t as 1 over r squared. Again, t equals to 1 over r squared according to our definition. And then we substitute 1 over r squared in this equation 3 by t. And found out actually that 1 minus 1 over r squared. 1 over r squared is t, so in total this expression will be equal to 1 minus t squared plus 1 minus 2 and 1 over r squared is t. So in total this expression will be equal to 1 minus 2t squared. 1 minus 2t squared. And it is equals to 1. So according to equation 3, I should found out that 1 minus t squared plus 1 minus 2t squared equals to 1. Here we open the brackets on this side of this equation 3, and found out actually that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared. Minus 2 times 1 times 2t, that is minus 4t, equals to 1. So here we have 1 on both sides of the equation. So 1 we get cancelled. After we cancel 1, in this side of the equation we left with t squared plus 4t squared is 5t squared. We also minus t minus 4t is minus 6t plus 1 equals to 0. And again, so if we found out that according to equation 3, t squared minus 6t plus 1 equals to 0. So actually this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Now a specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0. The variable that we are looking for is t, therefore x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. The only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we find out the value of the values of t, because x equals to t. So x equals to t, so we substitute x by t, and we actually found out that x equals to minus b, b equals to minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36. Minus 4 times a is 5, so minus 4 times 5 is minus 20, times c is 1, so minus 20 times 1 is minus 20, divided by 2a. A is 5, so 2 times a is 2 times 5, that is 10. So we actually found out that t equals to 6 plus minus square root of 36 minus 20 over 10. 36 minus 20 is 16, so inside the world we have to leave with 16. So we found out that t equals to 6 plus minus 16 over 10. The square root of 16 is 4. Therefore we found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So the first solution for t is that t equals to 1 from one side, but from the other side, according to our definition, t is also equals to 1 over r squared, and therefore we can substitute t in this equation by 1 over r squared. We did it, and we actually found out that 1 over r squared equals to 1. Here we multiply this equation by r squared, and finally found out that r squared equals to 1. Here we took a root out of this equation, and finally found out that the radius of the circle, the radius that we are looking for, is equals to the square root of 1, that is 1. So I actually found out that the radius of this circle is equals to 1 unit in its length. But it is actually impossible that the radius of this circle will be equal to 1. Why? Because of the fact that we know that chord dB equals to 2 units in its length. And from the drawing it is very easy to see that chord dB is definitely not the diameter of the circle. Again, chord dB is not the diameter of this circle. So if we again, it is given us a question that chord dB equals to 2 units in its length. And from the drawing it is very easy to see that chord dB is definitely not the diameter of the circle. But we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. What is the diameter of this circle? The diameter of this circle is of course equals to 2r. So the diameter of our circle is equals to 2r is the longest chord in the circle. And therefore, it will be definitely greater than dB, that is not the diameter of the circle. And dB equals to 2. And from this equation, we derive that 2r is greater than 2. Here we divided this equality by 2, and finally found out that the radius r of this circle is greater than 1. If the radius of this circle is greater than 1, the radius cannot be equal to 1. So this solution is a correct solution. So the possibility that the first solution for t that equals to 1 gave us a contradiction, and therefore this possibility is the correct possibility. We cancel this solution, and we'll have to only take into account the second solution for t. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 10, 2 over 10 is 1/5. So the second solution for t is that t equals to 1/5 from one side, but from the other side, according to our definition, t is also equals to 1 over r squared, and therefore we can substitute t in this equation by 1 over r squared. We did it, and finally found out that 1 over r squared equals to 1/5, Here we cross multiply this equation and finally found out that r squared equals to 5. Here we took out of this equation and finally found out that r, the radius of the circle that we're looking for, r equals to either square root of 5 units in its length, or in terms of numbers, the radius of this circle r, it is equals to 2.236 units. Okay? Thank you very much.